Okay, so here's the third part of Unit 9. It's number 19. And number 19 actually had 3 parts to it, but they all kind of go together. And so we really got to think about the quadratic equation. Remember, we learned that in the quadratic equation, the discriminant was the part under the square root. Okay, the part under the square root is the discriminant, so I don't really need the square root, but it was that square root part that determined whether we had imaginary roots. In other words, we got a negative number. And so if this was less than 0, we got a square root of a negative number, so it was imaginary. Oops, I keep hitting that button here. So maybe I should just erase it, and you get imaginary ones. Okay, but if it was positive, then we got real ones, and we got 2 of them. Okay, here we had 2 imaginary, and I can't write there at all. Okay, and then if it was equal to 0, you had plus or minus the square root of 0, which is 0, and adding or subtracting is the same answer. So you got a real answer, but it was only one real solution. So we're going to use that to do this. And so if you look at number 19, they all had used 19a, b, and c use this equation: ax squared minus 18x minus 3 equals 0. So we don't know a, which is what we're trying to find out. We know b is negative 18, and we know c is negative 3. So I always start, even though this was the second one you had to find, I always start with that one because it tells me my boundary, where exactly I get zeros. So I'm going to write b squared minus 4ac equals 0. And it turns out that means negative 18 squared minus 4, I don't know a, and then c they told me was, oh, I totally botched this. I think it's negative 3. Yes, it's negative 3. I don't know why I wrote negative 13. That should be right there. Negative 13 is gone. Okay, so I got that there, and that should equal 0. And that will give me this answer here. So it turns out that this is 324 plus 12a equals 0 minus 324 from both sides. And you get 12a equals negative 324 divided by 12, divide by 12. It turns a equals negative 27. So this is answer B right there, 27. Well, when you go to do A, it's the exact same setup except for one thing. For A, you get b squared minus 4ac has to be bigger than 0. We're doing this version here. We want 2 real solutions. Well, it's going to get the exact same answer, so you're going to end up with a is greater than negative 27. And the same thing with C. You want this one right here. You want it less than 0. b squared minus 4ac. All the numbers are identical to what we just did in B. What we did over here. So I'm going to get a is less than negative 27. So this problem really was only one problem with 3 interpretations depending on which side of the number line you needed to look at. Okay, so there's your answers there. And I really only required it on one of them to do the work, because the work is the same everywhere else. Okay, that's number 19. So we're supposed to do number 20 now. In number 20, we have the roots 7 and negative 3. Those are values that work. In other words, x equals 7 and or is a better way to say it. X equals negative 3. And we want to turn them into a quadratic equation. So if I add 3 to both sides, I'll get the factor x plus 3 equals 0. And if I subtract 7 from both sides, I'll get x minus 7 equals 0. And so since these are my factors, if I were to multiply them together, I would get a quadratic equation. So that's what I'm going to do. X minus 7, x plus 3. Now technically you're done. It didn't say which form it's supposed to be in, but if you wanted standard form, you can just FOIL now. X times x is x squared. X times 3 is 3x. Negative 7 times x is negative 7x. Negative 7 times 3 is negative 21 equals 0. Combine like terms, you get x squared minus 4x minus 21 equals 0. And this is what most people had for the answer. Now, it could be, if you wanted to, you could multiply all these numbers by 10 if you wanted. And it would still be right. And you could multiply them all by whatever factor you want. But this is the most basic one that people are getting. Okay, so that's number 20. Number 21 is very similar in that you're given two roots. So we know x equals plus 7 root 3. Or x, it's either and or really. They could both be 0. And then minus 7 root 3. So let's put those in the, so we're going to subtract 7 root 3 from both sides. X minus 7 root 3 equals 0. And plus 7 root 3 to both sides. And you get x plus 7 root 3 equals 0. There's our two factors. If we multiply them, we're going to get it. Now I'm going to use the trick. A minus b all squared equals a plus b, a minus b. So that's what I have this, and I have this and this in reverse order, so I'm going to get that. So I'm going to get x squared minus 7 root 3 all squared. Well, that happens to be 49 times 3, which is 147. And there's my quadratic equation for that particular problem. And again, you could have multiples of it as well, but usually most people are stopping it there. Okay, the last one, number 29 for Unit 9. I actually warned you guys you would have this on your test or on a quiz, and so I don't really think there's a reason to not get the points. You just had to memorize it, even if you didn't understand what to do. Now, I'd rather have you understand, so I'll explain it again. But the whole point of this is to get it. You're trying to prove the quadratic formula. They're trying to show that this is not some magic formula. So I'm trying to prove that. I want to end up with that. Excuse me. So, first thing is I don't like to do completing the square with a variable in front of it. So what I'm going to do is recommend that we divide everything by a. Some of you don't like that, but that's what I showed you to do. So x squared plus b divided by a, x plus c divided by a equals 0. Now I'm going to subtract c over a from both sides so I can start completing the square. I'll leave a blank there. And we have negative c over a. So what's half of this? Well, half of this is b over 2a That's half of it. And we're going to add that, but we have to square it. So I'm going to do the same thing, plus b over 2a. That's the part I added to the other side. And when I do that, I'm going to end up with a perfect binomial squared, x plus b over 2a all squared. And this is going to be actually b squared over 4a squared. And I'm going to write, that's what this part is here. I'm going to write that first, and I'm going to write this part second. So I get b squared over 4a squared minus c over a. Now, it'd be nice if I could combine those two fractions. That'd be really nice. But in order to do that, I'm going to need to have a common denominator that they both share. Well, if I multiply this times 4a on the bottom, I'll get 4a squared. So whatever I do to the bottom, I do to the top. Okay? And so that will turn out that I end up with b squared minus 4ac, because they'll both have 4a squared on the bottom. Like that. It's a little bit big, that too, so I'll make it a little bit smaller. Like that. And that's x plus b over 2a all squared. Now, again, we do something you've already seen done a bunch of times before. Square root both sides, because that's all squared. Put a plus or minus here. And I get x, whoops, I don't want green, I want black. X plus b over 2a equals. Now we've got to do some work on this. So when I do that, I'm going to split the square root. It's going to be all over the square root of 4a squared. So when I do that, that turns out that the square root of 4a squared is square root of 4, which is 2, and a squared square rooted is a. So this is really 2a. Okay, I'm going to go to the next screen and finish it off here. So here where we had that, and what I want to do is get x by itself, so naturally, like any person does, you do get rid of what's blocking with it. And I'm going to put it right here. So I've got this, this plus or minus is really, if I put it right, is right in the middle there. Well, we've got the bottom of this. Those are the same denominator, so it turns out I can add them. Whoops, that's not what I want. X equals, those go away, negative b plus or minus the square root of b squared minus 4ac. They all have a common denominator. And voila, we have just, that's French, by the way, for there it is. We've just proved the quadratic formula, which we'll never forget again.